In my last video I have proved that every filter is contained in an ultrafilter. So in today's video also I am going to discuss about few important properties related to ultrafilter. So let us start with the first one. In the first result I am going to prove that suppose we are considering a filter U, then it is an ultrafilter defined on X if and only if for any subset E contained in X, either E is a subset of U or X difference E belonging to U. This is a very important result actually. We can prove it in this way. Let U is an ultrafilter on X and E is a subnet on X. Actually you can write subnet of X. Then if E doesn't belongs to U, then E contains no member of U, or equivalently we can say that every member of U intersects X difference U, X difference E. So the family U union X difference E has the finite intersection property and consequently we can write, so it generates a filter, say script G, because you can provide the reason also why we have said this thing, because we know that if S be a family of, you can write in this way, since S be a family of subnets of a set X, then there exists a filter on X having S as a subbase if and only if S has the finite intersection property. We are using this criteria to say this, if and only if S has the finite intersection property. So this is the reason behind this, and obviously we can say that in this case, because U is maximal, so no filter on X can properly contain U, because as per our assumption U is an ultrafilter, that's why. So in particular we can say script G can be made equal to U, which implies that X difference E is a part of U and hence we have this relation, hence the result follows. Conversely, we can say let either E is a part of U or X difference U, E, that is belonging to U. Let us assume this one. If possible, let U is not an ultrafilter. U is not an ultrafilter. Then we can say that there exists a certain filter, say script G, which properly contains U, so that there exists E, which is a part of script G minus U. Now as per our assumption, U is not a part of U, E is not a part of U, E is not a part of U, and E, X difference E belongs to U because of this assumption. So you can write by hypothesis, hence X difference E belonging to script G, and that's why you can say that script G contains E as well as X difference E, but it contradicts the finite intersection property. Obviously finite intersection property of a filter, and hence we can say, so our assumption was wrong, and hence U must be an ultrafilter. So this is the required criteria. So this is the very important theorem. This is a very important theorem for your examination point of view. You can go through this proof. Obviously in such short videos it is not possible to explain each and everything, but I am trying to provide the actual solution or actual proof of these results. So without wasting any time, let us consider the second one. But before that we need few propositions. Obviously you can try to prove those also. Some important results are like this. You can consider them as proposition. An ultrafilter converges to a point if and only if that point is a cluster point of it. This is again another important proposition. I hope you all know what is the meaning of cluster point. And also there is another criteria, that for a topological space X, following statements are equivalent. This is again another important result, but I am just giving the definition, or better to say the statement. First one is what? Suppose X is compact. Second criteria is what? Every filter on X has a cluster point in X And the third criteria is every filter on X has a convergent subfilter. So these three conditions are equivalent to each other. So one implies two, or better to say implies B, B implies C, and C implies A. You can prove this one too. Even you can try to prove this one. If you have any doubt, you can provide your comment in the comment box section so that I can give you the proof. Now, what is our objective? We are going to prove another important result, which states that a topological space is compact if and only if every ultrafilter in it is convergent. This is also a very important result. So let us try to prove this one. Now, first part is very easy. If a space is compact, then every filter in it has a cluster point. Because of this reason, you can say A implies B. So if X is compact, then every filter on X has a cluster point in X. And also, in particular, every ultrafilter has a cluster point, as we all know it, and so it is convergent. So the first part is very formal, so you can easily prove this one, because already I have given the first corollary or proposition. An ultrafilter converges to a point if and only if it has a cluster point of it. So actually we are using these two results to prove the first part, but what we have to prove in the converse portion, then we can proceed in this way. Conversely, let capital X is a space with the property that every ultrafilter on it is convergent. Now, to show X is compact, we can utilize this criteria. We can use, for your convenience I am writing like this, we can use this criteria after showing that every filter on X has a cluster point. You can also give the statement here, but as I have mentioned the statement earlier, that's why I am writing this. Now let capital F is a filter on X. So because we know every filter is contained in some ultrafilter, so we can say then there exists an ultrafilter, say U, containing F. But by hypothesis we can say U converges to a point X. This is our assumption, obviously on capital X. then small x is also a cluster point of U. So every neighborhood of X meets every member of U, and in particular we can say every member of F, because F is the filter under consideration, as F is contained within U. So X is a cluster point of U. So every filter on X has a cluster point in X, and hence X is compact. This is the proof of this result. These two theorems are very important regarding your examination. I hope this video will be helpful for preparing your exam notes, and obviously if you have any doubt, please ask me your doubt. I will try to solve it, and thank you.